And this is a really good user case from Dematic with Kraig Rotman, where he's building toolkits within Emulate3D to reduce build time significantly, so really streamlining the model builds as they go.
Well, I'm Kraig Rotman from Dematic. If you're not familiar with Dematic, we're a supplier of automation technology, so warehouse solutions. So I work in our global project engineering group, and mainly with case conveyor technology. So we have lots of different technologies at Dematic. Our case conveyor is probably our largest business. So when I talk about what we're doing with Emulate3D, we're talking mainly case conveyor. We got a bunch of different technology groups using Emulate3D, so I can touch on that if you have questions about it, but I'm really just going to talk about the case conveyor solutions that we do in North America. So I've been working with Emulate3D for the last little over 2 years. We had one of our senior guys retire, so we needed some additional help.
There we go.
There we go. So I came in and started working with Emulate3D. Just a little background on where we're coming from. We have an engineering tool that all of our controls and mechanical engineers use. In Dematic, it's developed internally. It's based on a parametric graphical design platform from a third party. And it contains all of our design information. So we have everything inside the warehouse is really captured inside this design tool. So whether it's what type of materials we're handling, cable routing, cable connections, all that information is in there. And we export the data from this tool using the JSON format. So it's ends up being a really large file. Typically, the files are 100 meg or so. I had the privilege of working with the development team for the first couple of years when they were doing this. So when I saw the JSON export come through as a requirement, I was one of the guys that picked up that ticket that developed that. So a lot of the output here is kind of, I got to develop it for myself to use in Emulate3D. So it worked out pretty good. So on the Emulate3D side, a lot of the work, probably over half the work, was really developing the JSON parser itself. So I wanted to be able to have an organized object list in C# or in .NET that I could use. So we used Newtonsoft based on .NET parser, and there's a bunch of custom converters in there that actually convert the objects from our tool into .NET objects that I can query with LINQ and use that way. So one of our goals for developing this plugin to generate the models was to not have any dependencies on the Emulate3D scripts that each model uses. So in most cases, we're just using generic set and give properties from the visuals. And in those cases where we're using aspects, we use .NET reflection to set properties. Stay away from doing any method calls into the scripts themselves using the native object. So, so we developed a plugin, and the plugin is installed by opening a catalog. So initially, we started doing the plugin, installing it in the document scripts folder and doing the traditional plugin. But that was not very user friendly because every time an engineer had to use the plugin, it was such a pain. So this was a great way to push this plugin out for us. And the plugin supports regional catalog, so we have teams in Europe and APAC that use this as well. And they can use their own conveyor catalog with their own scripts, and the plugin still works and just pulls their models out of their catalog instead of the ones that we use in North America. It also helps for if we are in the transition from one catalog to another local project, we can maintain the same catalog and the same script behavior for that project. And the big reason we did it was reduction in build time. So, with the pandemic, automation just went crazy. I think we were looking to do twice as many models, I think, in 2020 than we did in the year before. So really, by getting this automation out there, we do about twice the amount of work, and the models are more complete, more complex than they were in the past. And the plugin also allows us to flex in engineers that maybe aren't as knowledgeable as with Emulate3D, but they can still use the plugin. They understand our conveyor and how it works. So the plugin basically automates the building for them, and they can fill in the rest. So it's really helped us flex in additional resources as well. So one piece of data that we don't capture from our design tool currently is our safety system. So we use a lot of functional safe PLCs and controllers. So what we have as another artifact in our engineering process is we do a safety planning spreadsheet. I wrote another little plugin that imports that safety planning spreadsheet and builds our safety design on that. When I first started looking at building this generation plugin, we have our previous system. We have probably 20 to 30 catalogs and just as many scripts. We had hundreds of scripts. So every time we added a photo eye to a conveyor, it ended up being a different script. Every time we changed how a piece discharges, it was another script. So we had scripts just everywhere. And that wasn't going to work for generating the conveyor. Because otherwise the model or the generator, the plugin would have to know too much about how this is going to operate. So what we did was started to redesign our catalogs so that the scripts are modular. So we would have a script, a photo eye that is connected to this conveyor, it would know how the conveyor would need to operate them. And yeah, so the main reason was to make it easier for auto generation. And it also allowed us to greatly reduce the number of scripts we had and have tested scripts every time. So we wouldn't have a custom script on this model just for adding a photo line. So we definitely made a lot of that came about by using more implementing custom properties and visual referencing, which we didn't do much before. So that was goals for just overall for the e-stops and the safety system. We typically would basically brute force the safety script in our conveyor. So every model would have a custom safety script written that would tell the model how the safety system is supposed to work, which was a lot of work, but also prone to lots of fat fingers. So what we did here was all of our safety devices now are visual referenced, and we don't have any custom scripts on models. It's just all referencing, which helped our generation as well. And then the drives. So the conveyor drives really drove a lot of our custom scripts. So whether we were using Muscala or Rockwell, Bradley, or whatever drive we were using, it ended up being a different script every time. So we had to have script the drive, and then they would script the behavior of the conveyor. And they were all meshed into one script. So that gave us a lot of different permutations. So now we separate out the conveyor behavior from the drive behavior, and the visual is just connected to the conveyor visual, and it drives the conveyor behavior from that. So, and this works out great too, because if we build out a system and the engineer just needs to make a change to one of the drives, say he was using just a contactor and wanted to make a free drive, he can just swap out the visual, and we don't have to change anything or have to revisit it as an emulation engineer. So, yeah, this is just an example of our conveyor and how we changed it to be more of a modular design. So you can see from our visual reference there, we have a drive that's attached to it. Then we have the orange represents a full photo for basically an interface point from the PLCs. And there's a cable that goes there. And then on the discharge end, we have those relay cylinders, which are release points or release control modules. So what we do is we build a conveyor, and we can just drop on the components we have. We don't have to change any scripts. They don't just work now as a model. And then one other thing we did was to expose the properties for how the model operates to make it similar to what they would see in the field. So if we're in the field and commissioning this conveyor, there is a dip switch for like look ahead, so the LA. So every engineer at Dematic knows that if they turn the look ahead or LA on, it's going to behave in a certain manner. So now when they're in the emulation, they see the same nomenclature and properties as what they would see when they're commissioning in the field. And then visual aspects. So we're still looking for a good reason to use visual aspects. And this ended up being a great solution. Now that the binding properties, we may use more visual aspects in the future, but what we did was data coming over from our design model didn't always line up with the data for the properties in the visual. So when I have a case like that, instead of putting that logic in my plugin to do a special handling of how maybe like the wedge works there, I add an aspect. So in our catalog, we have an aspect added that basically gives us the exact same thematic property. So the plugin actually just takes the property from the JSON information and just transfers it to the visual, and the visual handles represent itself properly. So like in this case, we have to create a length on an injector, and the aspect adds a length, and then make sure that it's represented correctly. Side channels was another one that we implemented on every conveyor that we have, so we get side channel information that helps us so we can represent the unit correctly, and it really helps when the engineer sees the side channel here. It's just really represented the same as when he goes to see in the field, so it's really helps to make it more realistic. Yeah, meter bed's pretty much the same thing, just mapping our properties from our design tool directly over. It also helps for, if the engineer has to make a change to the model. He's familiar with what these properties do in our design tool, and they behave the same way in the emulation model. So let me see here. Do a quick demonstration of our plugin. We just have a toolbar here. Pretty simple dialogue. One thing, when I first started out, I was using a lot of third-party controls and found that they didn't always publish well with the way the plugin works. So stuck mainly with native controls and .NET. And if it was up to me, we just have one button here, no interface at all. But this is just all of our information coming over from the JSON file. And I just have a couple tabs here, one for conveyors. So in Dematic, everything is associated to a unit. So we try to connect every device to a unit. Sometimes there's devices that are not connected to a unit, so that's why we have another one, so we generate some devices that aren't connected typically. And then we have a levels. I'll show what the levels does after this. And we just have a way to basically reposition the conveyor. So I try to use the same coordinates as we do in our design system. But usually it ends up like way off the canvas over in other areas. So just have the same here to move the 0, location to the closest conveyor. So this is the conveyor system that just built here. It comes in pretty much complete.
Kraig, if I may.
Yeah.
In case anybody missed what just happened there, and if you're, especially if you're newer to Emulate3D, if you've ever heard the term framework, when we talk about Emulate3D and we say Emulate3D is it's all these things, but it's a framework. What Kraig's done here is created his own application within Emulate3D, his own plugin, and he's just generated that whole model in the blink of an eye. And I think that's just awesome. So thank you, Kraig. Great work.
Yeah, it's really cool technology. So this levels is kind of like a holdover term from our engineering tool, but it really means floors. Okay, so if I generate this, I can see like our mezzanines as well come in here. So there's a couple different mezzanines, and then there's holes for each of them. There's the transverse from floor to floor. So that's been useful as our conveyor models get more complex and we do more 3D multi-level conveyor. Maybe just in the past, the conveyor systems, since they were building the conveyor models by hand, we would pretty much just do it on one level, so everything would be a meter off the floor, and where we had inclines, it would just be a flat conveyor. So by having this plugin, it really gives us a lot more depth in how we see the model behave, and it's more real. So I can just do a quick demo here too of our e-stop. So this is where we import the safety data. So I just imported the safety data from our planning spreadsheet, and it tends to go, so if the engineer does this correctly, these names should match up. In this case, even the same. So I have to manually associate the e-stop safety zone with the visual that's represented in the drawing. So since these all have been correctly, so I can just generate this one safety zone here. That was this one. Yeah, so by doing that, it basically links up all of our safety devices. And yeah, so the safety system works without any scripting. I mentioned this was one of the most time-consuming things with building a model was producing all these safety scripts that were done pretty much copy and paste and enforced. So we have another little tool that we developed here just to allow you to view the safety devices that are defined. So this kind of just another view, so I can manually add these steps in here. Then all of our drives and other conveyor that consume or participate in the safety device can be configured here. Yeah, this data is not in our design tool either. I can just assign like all these motor drives to a particular safety circuit that I can try to use. So. And if we want to do it manually, we just drag and drop a device to us. So that's kind of plugin stuff. Another thing that we've been working on heavily is we were finding that with the scripts, the emulation engineer would take the data from the engineer. So we had some configuration data on how our motorized roller was working. And the engineer would basically take all that information and apply the correct scripts to each zone. And we found out that one of the problems was that data would change from the time we built the model to the time the engineer actually went to use the model. So that was a problem. but also the engineer didn't really understand how the data they created was getting used in the model until they went to site, and they would see that, oh, this is what the data was doing, because the emulation engineer would take that data and apply the scripts and set it up correctly. So we found that making the model follow the on-site workflow really is great for making that better model for one, but also getting the engineer prepared to understand what he needs to do on site when he gets to site. So, yeah, so we have improvement functionality as well as training opportunities preparing the engineer. Yeah, so let me go back to the model here. So the MBR here. So maybe I should explain MBR. MBR is just a motorized driven roller. So every one of these zones has its own motor. And this device here is actually the controller for that. So it's this device has its own intelligence. It's an embedded controller. And that's going to dictate how those zones run. And in our system, we have a interface to the PLC, which is our gateway. So this here represents the gateway. This is what the PLC interface is with, but we have this visual reference list that represents our network. So these devices are all networked together to the gateway. So this is how we reference those together. And the way we use our configuration data then is to just load the configuration. So this is the exact same configuration file that we need to go to site with mission. You just open it here, the model is smart enough to open that and interpret it. And it builds the IO interface here, that's custom properties. So the PLC is going to interface here just as it would, if we could do the class 1 devices before. But we just basically map this to our IO tree data, PLC. One thing is that configuration file, since I didn't have a good way to connect to the serializable interface in Emulate3D, I store this configuration in a string, and then I can serialize or save the file. See, so those all talk to the devices, and then these devices here have a bunch of different things that affect how it operates. So what we did was took our entire parameter list that we use on site when we configure this, and it's all loaded in here. So when the engineer goes on site, he can see that this parameter here is 7, and he knows how that's going to operate on the site. You can see it reflected here. So that's really helped having the same terminology in the model as what we're going to see on site. And so the last thing that we did was this gateway here. Actually, on site, we have a socket that we use, a configuration socket. And in the emulation as well, I have the same socket connection. So I can, instead of opening sockets for all these devices, sometimes we'll have 20 or 30 gateways in there that want to open all the sockets in one area. We open the socket up here, and I can launch my software that I use on site. See, we just have a different connection method for the emulation, because on site we typically only, or we connect to a single port, or in the emulation I'm connecting to a single IP with multiple ports. So this connection information has to be just somewhat different. But, so I'll connect up to the model, and you'll see these are all devices that are part of that network. So I think I can go in. So all these screens here work just like they do on site. And I can go in, I can read parameters, say like parameter 13 here, I can change the way it operates to 2. I can actually find the file here. Yeah, like like look at node 5 now, the custom properties changed to 2 in here. So as the engineer is working with the model, it's the exact same workflow that you see on site. He's going to work with the same tools, and it's going to operate and behave the same way. So you can change speeds and change operation right interface here. And you can actually use like our run screen here to jog the motors just like you would on site. That might be everything I was going to cover.
Wow. That kind of knocked my socks off, right?
Yeah,
Great job.
it's been great. We get, probably Steve probably gets 4 or 5 calls every week, but we get calls, from our engineers that are using it. And they're like, oh, your script is broken. It's not working correctly. So usually we end up going through it and we find that, oh, there's an issue with the configuration file. We haven't changed the script in 2 years now, so. But we get calls every day saying your script is broken. Like, no, it's your engineering data. So go back and look at your program, look at your configuration data, your parameters. So it's been a great tool.
Pretty interesting. We actually, in the simulation department at Dematic, have a very similar tool that we developed in Excel to get the Meister models into Demo3D.
All right. Kraig, thank you so much.
That was a fantastic presentation. We appreciate Kraig giving that. Are there any questions on that presentation? Do we have Kraig online with us?
Yeah, let me see if I can get him unmuted. Oh, he should be able to unmute himself now.
Hi, everyone.
Hi, Kraig. How are you?
Hey, Kraig.
Do we have any questions for Kraig? One that I have, and maybe you could answer as shortly as possible, Kraig, is, your importer, right? The ability to simply create those models is one of the amazing things, I think, that when people see that for the first time and didn't realize that could be done, are pretty blown away. Can you give us some idea of the challenge of the scope of creating something like that as a user?
Yeah, actually, I've done similar projects with other tools as well. So I think Emulate3D was, it's a very complete API, and really the challenge was more of just getting the data and organizing the data versus actually using the API. And Emulate3D, I found it very intuitive and straightforward, and I had a lot of questions back and forth with support, as Mike and everyone knows, but yeah, it really was not bad at all.
Well, that's great to hear. And that question was not rehearsed. It's just something I really love people to hear from the horse's mouth, so to speak. Sorry, Kraig, didn't mean to metaphorically represent you as a horse, I suppose, but appreciate it. Any other questions?
Yeah, I've got a question for him actually. So, do your customers ask for this? Do they require ever virtual commissioning projects from you, or are you mainly just doing this because it's a competitive advantage for you? It's like your secret sauce.
Yeah, I can't say that we've ever turned it over to a customer. We have several customers that will come in and view it with us. But yeah, it's definitely an advantage, and it's part of our engineering process. And our goal is to have 100% of our software checked out in site before we leave. So I think Allison is on the call and she knows, but I think I checked in August and we did 250 models, I think, by August already. So we've about doubled the number of models that we build year over year. So
holy cow, that's amazing.
Wow. Great
That's
work.
awesome.